Hi, this is Mike, WB4HUC, and I thought I was done with these two little programs I wrote a couple of months ago. One reports the status of various settings inside the KPA 500. The other reports the status of various settings inside the KAT 500 tuner. Well, the amplifier program has pretty much worked from the beginning. The tuner program has had some problems. And what puzzled me was the tuner program was basically a copy of the amplifier program, except that uh, I made the changes for it to talk to the tuner instead of the amp. But the structure of the program, the logic, all of that stuff is the same. It's just the part where you send the commands and get the responses is different between the two devices, but the overall layout of the programs are the same. So when the tuner program sometimes wouldn't work, I couldn't figure out why. So I went through this debugging session with the tuner program and couldn't figure anything out. I couldn't really understand what was happening. I could tell that it was hanging up on a particular line of code, but I couldn't tell why. So when all else fails, read the manual, right? So I went back to the KAT 500 programming guide, and right in the front of the manual, I see this. So this paragraph, beginning with firmware version 01.38, the microcontroller may be configured to sleep when logically off or otherwise idle. It takes a few serial port characters and about 100 milliseconds to wake up, and characters sent during the wake-up period may be lost. The KET 500 utility sends semicolons at approximately 100 millisecond intervals until the KAT 500 firmware begins to respond. See the SL command. The SL is the sleep command. Turn it on, turn it off, or ask how it is set. So there it was, staring me in the face. So it appeared, from what I could tell, that this might be the problem. The tuner might have been in sleep mode while I was trying to talk to it, and the coordination between the two was just sort of screwed up as a result of that, and it wasn't working right. So I thought, how can we verify if sleep mode is on or not? Well, let's use the KAT 500 utility program from Elecraft. So we go to Edit Configuration. Sorry. We go to Edit Configure. Huh. Oh, I know what's happening. I'm sitting here trying to figure out why this thing isn't working. You can't have two things talking to the same serial port at the same time. And I already have this active, so I apologize for fumbling around, but now it should work. There we go. So anyway, we go to idle sleep, and it's not checked, which would indicate that sleep when idle is turned off. Yet, like I said, the behavior of my program, it was sort of behaving as though it sleep when idle was active. So I thought, well, how could that be? How could it be on when the program reports that it isn't? And the only thing I could figure out is maybe somehow some bits got flipped inside the tuner that caused sleep mode to be active when the program reported it was not. I've had the tuner for about 10 years. I've had it a long time. I don't ever remember playing with sleep mode, but who knows? Maybe the tuner got discombobulated at some point, and unpredictable things happened. Who knows? I don't know. So, so anyway, I'm thinking, well, what can I do to deal with this? So I went into the program that I wrote and added a line of code. So we go down through all of this stuff, and here we execute this procedure called proc initial connection. And so that's what this procedure does. So here's the beginning of the procedure where we define it. And all it does is sends semicolons to the serial port and out to the tuner, and the tuner should respond with semicolons. So if I send 1, 2, or 3 semicolons to the tuner, I should get 1, 2, or 3 semicolons back from the tuner. And all that does is indicate that the communication between the tuner and the program is working. Well, if we remember what the book said, if you're already in sleep mode, then the first few characters you send to the tuner could be lost. Well, we thought about that. So here we put our semicolons to the tuner. We wait. Uh, this is basically 100 milliseconds. So this value is 1/100th of a second. So if we wait 100, that's approximately 1 second. And if we wait 10, that's approximately 100 milliseconds. So after we wait, then we look at our characters, and this is a command that interrogates the serial port buffer to let us know how many characters are there waiting to be read. And if we get 0, then there are no characters in the serial port buffer, and we assume that the serial port isn't responding or isn't working, whatever, and we end the program. Well, that was not happening. There was something in the buffer. So we got past this and we went down to here, and we we initialize our tuner response variable, and then we read, excuse me, we read the characters that are in the buffer, put them in the variable. And if we got down to here and we got something in our variable, then we assumed that we were okay. So then all I did was execute this command, turn the serial mode off, explicitly turn it off. Well, once I executed or sent this command to the tuner, everything started working like it's supposed to. There were no more delays, there were no more hang-ups, everything was working right. So I thought, okay, we're onto something. So originally, this was not a repeat loop. Originally, uh, it was just this code here. So we would execute this once, and it seemed to be okay because even though we weren't getting our semicolons back, we were getting something else. We were getting something. So the tuner was waking up and it was becoming responsive, at least for a little while. And, we could continue on until something happened that it went back to sleep. So I thought, well, maybe there's a little bit better way. So I added this repeat. I just added these 2 lines to turn this into a loop that repeats until we get our semicolons. So, like I said, the first time we do this, if sleep mode is on, we're going to lose these characters, but we're going to get something back. We don't know what it is, and it'll work. Well, so I changed it so that if the tuner's asleep, we send these characters, we get something back, and then we check. What we want to see is that the response from the tuner is equal to the characters that we sent, that we get back exactly what we sent. If it isn't, we go do this loop again. We send the test characters to the port, we wait, then we look and see what we get back, we process it, and the second time, then the response that we get back should be equal to the semicolons, and so we truly know now that we're communicating with the tuner. Then we continue on with the code. We execute this. So even if sleep mode is off, we still explicitly turn it off. Since I don't know how it got that way to begin with, where sleep mode was apparently on, uh, even though the Elecraft program said it wasn't. Well, I don't know how it got that way. So this is just a sort of an insurance thing. Normally, you'd only execute this once, It would stay that way until you change it. It's set and forget. But since I don't know what happened, I just leave it in here. It doesn't hurt anything. And then we end the proc and we go back and we start executing the rest of the code. So that fixed my problems. And how can we kind of take a look at sleep mode and what it does and how it operates? Well, there's a way to do that too. So just for fun, uh, we'll start up my version of the Elecraft command tester. And this sort of simulates or emulates what the Elecraft utility programs do. They have a tab that says command tester. You can send commands directly to the device and get back responses. Well, I didn't need all the other stuff that those utility programs do, so I just decided to write one that just does the commands. So for the tuner, he's on serial port number 2. His baud rate is 38400. And now we're ready. So, for instance, we can see firmware version. What antenna are we on? And then what is sleep mode? And we get back a 0, so we know sleep mode is off. So, and you notice that as soon as we entered these commands, we got back a response immediately. So let's turn sleep mode on. We got back some sort of response, but it isn't a printable character, but we did get back a response of some sort. So we're keeping on. And I'm going to watch my clock down here. And after several seconds go by, we'll enter a command and see what happens. Let's just enter our 2 semicolons like we do in the reporting program. Well, we got back this. It's not 2 semicolons, but it is a response. So that's why it kind of worked the first time, because the tuner did wake up and we did get some response back and we were able to communicate with the tuner. And then, as I said, I added a little loop to make sure that we do it until we get our 2 semicolons back. And usually on the second time, we get our 2 semicolons. And once we do that, the tuner's awake. But it seems to go to sleep fairly quickly. So if I interrogate sleep mode, so I had to keep going until the tuner was fully active again, and we see that sleep mode is on. So let's turn it off again. And if I'm too slow, okay. So one of these took, and now sleep mode is turned off again. So that's sleep mode. It seems to go to sleep fairly quickly when there's no activity. And if you wake it up by sending characters to the serial port, you lose your first few characters you send. And then once you establish communications, again, you need to do what you're going to do pretty quick. So 100 milliseconds is incredibly fast for us, but it's a long time inside a computer. So anyway, it all works out. So that's it. I just wanted to sort of mention this in case anybody is doing any sort of coding their own program for the tuner or the amp or whatever. This is just something to be aware of. For me, it kind of snuck up on me and caught me by surprise. But it's working now. So let's just put this in here. So it's working now. So if I push the band button on the amplifier, you can see that we went to 20 meters, we went to 20 meters, there's our frequency, there's our frequency. If I swap A and B on the radio, so I'm going to push the AB button and swap, and you'll see down here we swapped. So everything's working, and it's working like it should. So there you go. All right, that's going to be the end of this video. So I just wanted to talk about this. And in the next video, I want to talk about a debugging tool I used. It's called Serial Port Monitor. Shows you the activity that goes, the data that goes back and forth across the serial port between the computer and the device. And I don't think I could have developed these two programs as quickly as I did without it. It was very useful to be able to see exactly the data that was going across and how it was going across and how it was coming back and what other things were going on that you didn't know until you saw that kind of a thing. So I'll do another shortish video about the serial port monitor, and that should be hopefully, if you weren't interested in this one, maybe that one will be a little more interesting. It's a little more technical. So anyway, thanks again. I appreciate it, and see you next time.